Here in this building, researchers are working on a scale we can't even imagine. We're talking so small that thousands of structures could fit across one human hair. This here is a semiconductor fabrication laboratory. Very unique place to be. It is a place built to build, shape, and measure things on the atomic level. It is so sensitive that even light needs to be filtered, and that is why everything here is yellowed. We need to dress up in full protective gear and explore all the different pieces of equipment today. Let's head inside. As you can see, before we head inside, we have to suit up. But not for our protection. This gear is actually to protect the process itself. When you're working at the atomic level, even the tiniest dust particles or a single strand of hair can compromise everything. Nothing is left to chance. The solvent bench is our starting point. This is where wafers get cleaned, old chemistry is stripped off, and the spin coater applies a fresh, even layer of photoresist to the wafer. The wafer spins at high speeds while a drop of photoresist spreads outward into a perfect uniform film. As you can see on screen, the wafer changes colors. This isn't a trick of the camera, rather the iridescent quality is a result of the photoresist spreading across the wafer. You know the process is complete when the wafer becomes a uniform green color. After every step, the bench needs to be cleaned extensively, so there is no excess particles that can cause issues to future wafer development. Next, a second chemical is dispensed onto the wafer, forming a uniform top layer that builds the structure needed for the next fabrication step. At this scale, you can't measure anything with a ruler. You need light. The jaw ellipsometer is the lab's precision measurement tool. It fires a beam of polarized light at the surface of the wafer, then measures how the light changes as it reflects back. The light bends and shifts when it passes through the thin film, and the ellipsometer is able to measure the thickness of individual layers, down to the fraction of a nanometer, a single atom. Every deposition and oxidation process gets checked here to make sure the layers are exactly the right thickness. If they're not, the whole chip design could fail. This machine is the quality control checkpoint. This machine is the photographer of the lab, the Quintel contact aligner. Here's how it works. The circuit pattern we want to print is etched onto a glass plate called a mask. Think about it as a very precise stencil. That mask is placed over the wafer, which has been coated with a light-sensitive chemical called photoresist. The aligner then positions the mask with microscopic precision and fires a blast of UV light through it. Wherever the UV light passes through the mask, the photoresist chemical changed. Wherever the mask blocked the light, it stayed the same. The result is an invisible image of the circuit pattern, waiting to be developed. After the wafer is exposed in the aligner, it comes to the base bench to be developed. A chemical bath washes away the photoresist in the areas that were exposed to the UV light, revealing the circuit pattern underneath. The final machine is the semi-tool spin rinse dryer. After the wet chemical process, the wafer needs to be rinsed and dried completely. Even a microscopic water spot could ruin everything. You can't wipe it with a cloth, you can't blow it dry, so instead we spin it. The SRD sprays the wafer with ultra-pure deionized water to rinse away any chemical residue, then spins it at a high speed. Think of the world's most expensive salad spinner. Until every last drop is flung off by the centrifugal force, the result is a perfectly clean, perfectly dry wafer, ready for the next step in the process. What happens in this lab doesn't stay here. The techniques developed and refined in research facilities like this one find their way into the chips inside our phones, your car, your medical devices, technology that most people interact with every day without ever thinking about how it's made. Now you know a little bit more about the technical process of this development.